Modern wars are no longer won by the strongest single platform, they are won by the best connected force. In today's battle space, it is not aircraft fighting aircraft, but networks fighting networks. The side that masters the flow of information holds the ultimate high ground. This conceptual shift is known as network-centric warfare, and it has fundamentally changed how militaries think about combat. It transforms individual asset sensors, shooters, and commanders into a single, cohesive operational system. This video will explain what network-centric warfare truly means for modern military operations, and why it is the defining principle of current and future air combat. Historically, military strength was measured by the quality of individual platforms. Doctrine was simple: build the best fighter, the strongest radar, or the fastest missile, and you would gain an advantage. Network-centric warfare inverts this logic. The focus shifts from optimizing standalone platforms to engineering a superior integrated system. In this model, no single asset needs to be perfect, because the network itself compensates for individual limitations and exploits collective strengths. A fourth-generation fighter, for example, can become exponentially more lethal when fed targeting data from a fifth-generation sensor. The operational takeaway is clear. Strength now comes from connection, not isolation. This leads to the second core principle, the separation of sensor and shooter. In traditional combat, the platform that detected a threat was almost always the one that engaged it. Network-centric warfare decouples these functions. The sensor, which could be a stealth aircraft, a satellite, or a ground-based radar, may not be the shooter. The shooter, such as a missile truck or a non-stealthy strike aircraft, may never even see the target directly. Targeting data flows seamlessly across the network, allowing for unprecedented operational flexibility. This separation enables longer engagement ranges, enhances the survivability of high-value assets by keeping them out of harm's way, and allows commanders to use their forces in more creative and effective combinations. The new reality is that the entity that detects the target no longer needs to be the one that fires the weapon. Third, network-centric forces are designed to operate in a distributed manner. Instead of concentrating forces in a predictable location, assets are spread across vast geographic areas. This distribution makes the force inherently more resilient. Individual units are harder to find and target. The network is designed with redundancy, reducing the risk of a catastrophic single point of failure. Even if an adversary manages to degrade or destroy one part of the network, other nodes can take over, ensuring the mission can continue. A single squadron of fighters operating from one airbase is a liability. The same squadron dispersed across multiple austere locations, all linked by a resilient network, becomes a far more complicated problem for an enemy to solve. The operational insight here is that distribution directly translates to resilience. The fourth advantage is decision superiority. A well-designed network dramatically compresses the OODA loop, the cycle of observing, orienting, deciding, and acting. Information moves from sensor to commander to shooter at machine speed, enabling forces to adapt and react far more quickly than an opponent. The side with the faster, more reliable network can process battlefield information, make sense of it, and execute decisions before the enemy even understands what is happening. This is not just about communication. It is about creating a shared, real-time consciousness across the entire force. In modern warfare, decision speed is a direct outcome of network performance. However, this reliance on networks creates a critical vulnerability. These intricate systems are powerful, but they are also fragile. Can be attacked through electronic warfare meant to jam or deceive communications, through cyber attacks designed to corrupt data or disable nodes, and through the physical destruction of key infrastructure like satellites or command centers. Consequently, modern warfare is as much about attacking the enemy's network as it is about defending your own. The contest for information dominance is now a central theater of war. The crucial takeaway is that network defense is not just a support function. It is a direct form of combat power. To understand how these principles converge, consider a realistic scenario. Stealthy F-35 detects a formation of enemy aircraft far beyond its own missile range. Instead of engaging, its pilot transmits the precise targeting data through a secure data link. That data is routed through a command node to a squadron of F-15EX fighters operating hundreds of miles away. While outside the enemy's sensor range, the F-15s, loaded with long-range air-to-air missiles, launch their weapons using the F-35's data, never turning on their own radars. The enemy aircraft are destroyed by a threat they never saw, from a platform they never detected. In summary, network-centric warfare has transformed modern combat. Platforms still matter, and weapons still matter. But it is the network that connects them that increasingly decides the outcome. Victory in the 21st century will belong to the force that can connect its assets, protect its data, and adapt its strategy faster than the adversary. If this analysis helped you understand the complexities of modern warfare, like this video and subscribe to Cut Everything. In our next episode, we will explore how stealth platforms are designed to operate inside these complex, networked environments. Comment below with your thoughts. Has network dominance become more decisive than traditional air superiority in modern conflict?